Hi everyone, in this video we're going to learn how to use combinatorics to count the number of ways to obtain Texas Hold'em poker hands. So just to review here, the formula for combinations is something like this. You have C, N, R, and that's N factorial divided by N minus R factorial divided by R factorial. But basically anytime you see something like this, so N R, you just punch it into your calculator. Sometimes you're gonna see something like this, N R. There's many ways. Even you'll see like N C R. All of that means the same thing. Just find it in your calculator, and then you'll be able to punch it in. The original formula is more just for conceptual understanding and how to derive and manipulate these things. But basically, you just punch stuff in. Okay, so let's start right away with the straight flush. So a straight flush is straight means you have 5 cards that follow each other. So in this example, we have 5, 6, 7, 8, 9. A poker hand always holds 5 cards. And the flush part means that they're all spades. So let's just try to think like how many ways are there to have a straight in poker. Well, you can start with the 1, 2, 3, 4, 5. So that's 5 cards in a row. And then this would have 4 ways of happening, right? It's either you have a heart, diamond, spades, or clubs. Okay, so there's 4 ways to have that one. And then you have the 2, 3, 4, 5, 6 straight. And then all the way down to 10, jack, queen, king, ace. Note that the ace is both a high card and a low card when it comes to straight, but when it comes to a high card itself, it's never worse than 2. It's always better than 2. It's always the best single card. So there's 10 possible straights, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each of them have 4 ways. So again, if you just do 10 times 40, so there's 10 ways to have a straight times 4 ways each. You can always multiply. When you say and, you multiply, and when you say or, you add these things. So 10 times 4 is 40. Another way you can think about it, you have 10 possible straights. You choose one of them, and then each straight, you have 4 possible suits for them, and you choose one. So then again, that would be 10 times 4, which is 40. So now let's move on to the 4 of a kind example. And a 4 of a kind is that you have 4 of a particular rank. So again, let's try to review the ranks. So you have ace, or I'll start with 2. Maybe that will be better, and I'll draw in green here. So you have 2, 3, 4, all the way to 10, jack, queen, king, ace. So that's 13 ranks. The word is ranks. And then you have 4 suits, right? The suits is the colors, not the colors, but heart, diamond, spades, clubs. So 4 suits and 13 ranks. So for your 4 of a kind, you have 13 ranks, and you choose one of them. So for example, in the example, it's the aces, but you could choose like an 8 or a 10 or a jack or whatever. And then out of the 4 suits, you need to choose all 4 of them because you have a 4 of a kind. So now you have 4 cards in your hand, and you're missing one. So how many ranks do you have left? Well, you chose one of them, so that one's gone. And then so you have 12 of them, and you choose one for your 5th card. And then you have 4 possibilities for the suits, and you just choose one for that card. So when you punch this in, you'll get 624. And that's 0.02%, because we'll see at the bottom, but we divide by the total possible ways to choose 5 cards from 52 cards. So when you divide by this amount, it gives you 0.02%. So now let's move on to a full house. A full house is you have a 3 of a kind and a pair. So again, let's apply the same logic. You have a full house, so you have 13. Choose one for your 3 of a kind. So 3 of a kind, you have 4 suits. You choose 3 of them. So that's the 3 of a kind. So, and then you have and, so that's a multiplication. You have 12 ranks left. and then you have 4 suits. So then you choose 2 of them. So then that would give you your 5 cards. So when you punch this in, you should get 3,744 or 0.14%. You can see that these hands are still pretty rare, and that's why they're good hands, right? So then the flush is you have 5 of the same colors. They don't need to be in a row because otherwise it'd be a straight flush. So again, for a flush, you have 13 ranks. And can you have 2 of the same cards? No, right? Otherwise that'd be a pair or something. So you need 5 unique, distinct ranks, and each of those card needs the same suit. So then you have 4 suit, and you just choose 1. Because you'd have, there's many different ways to think about it, but that's one way. But then there's one important thing, because they could be straight. When you pick your 5 ranks in a row, what if you picked 1, 2, 3, 4, 5? Because these would be all of the same suit. So then that's not good because we already counted. That'd be a straight flush. Then we need to minus our straight flushes. You can't double count. Okay? So you just minus your 40 straight flushes that we calculated in the first row. And the same kind of deal will happen with the straight here. So again, to calculate a straight, what you need is there's 10 different straights. 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, all the way down to 10, Jack, Queen, King, Ace. So there's 10 straights. You choose one of them. And then do you need the same suit? No, each card can have whatever suit it feels like having, right? So you have 4 suits for the first card, 4 suits for the next card, 4 suits all the way to the 5th card. So we just do multiplied 5 times. So that's exponent 5. So that'd be 4 to the 5 essentially. But then again, you might get unlucky by this and that they all have the same suit, right? That'd be unlikely, but that happens. So then you need to subtract your 40 straight flushes to give you the answer. So that'd be 10, like 10 choose 1 is just 10, 4 choose 1 is just 4, so that'd be 10 times 4 to the 5 minus 40, and I believe this should give you the 10,200 in this case. Now if we move on to a 3 of a kind is that you have 3 cards of this same rank and 2 random ones. If those two other cards were a pair, then you'd have a full house. So that's crucial here. So let's pick our rank for the 3 of a kind. So that's 13 choose 1. You have 4 suits for that one card. How many do you choose for 3 of a kind? And notice that the C is for combination, but often you can think about it as C for choose, right? You have 4 kings, you choose 3. And then how many ranks do you have left? Well, you chose 1 for your kings, so you have 12 ranks left. And the next 2 you need to be distinct. So you picked 2 ranks, and then each of those cards can have whichever suit it feels. So it'd be 4 choose 1 times 4 choose 1, or you can do exponent 2. And then here I don't think, no, they can't be all straight because you have 3 kings, right? So you can't have 5 cards in a row. And the fact that you have 3 kings prevents the fact that you have the 5 same suits. So you don't need to subtract anything here. And then we're going to move on to 2 pair. So again, you have 2 pairs. So that's pair 1, pair 2, and then you just have like a card, a different card. So let's choose our 2 pairs. So you have 13 choose 2. So you choose your 2 ranks. And then for the first pair, you have 4 suits and you choose 2. And then for the next pair, you have 4 suits and you choose 2. And then the last card, well, how many ranks do you have left? And notice that anytime you do something times itself, you can just do exponent. So, and then for the last card, you have 11 suits at 11 ranks left. Then you have 4 suits for that card and you just choose 1. In this case, again, it's impossible to have a straight or a flush, so we don't need to subtract anything. Okay, two more rows to go. We have one pair, so that would be one pair, and then three cards that don't have the same rank. So let's choose our pair first. We need a rank for our pair, so 13, choose one. And then we have four suits of aces in this case. We choose two of them for a pair. So then, and how many ranks do we have left? We have 12 because we only chose one. Then we need three unique ranks. And then each of those cards have four suits. So then you have four suits, choose one times three because you have three of those cards. And that should give you 1 million. So that's pretty common. It's almost, it's 42%. Almost half of the time you have a pair, which is pretty solid, right? And then a high card is when you have five distinct suits. So five distinct ranks. So in this case, your best card would be the king, okay? So then you have 13 ranks and you choose five unique ones. And each of those cards, so it'd be four, choose one, yet has a suit, but then you have five of those, right? So to the five. But then it's possible to have a couple of things. It's possible to have your five ranks in a row, which would give you a straight. So we need to subtract the straights. That's minus 10,000 to 100. And then you also need to subtract the flushes, because it's possible that when you four choose one five times that they're all hearts, for example. So we need to subtract the 5,108 flushes. But it's also possible that they're straight flushes, so minus 40. So that would be the straights. That would be the flushes. I'm not sure how to spell that. And then that would be the straight flush, right? And when you do 13 choose 5 times 4 to the 5 minus those three numbers, you should get 1,300,000-ish. And then that should be roughly half of the time, because here it's just you have 52 cards and you choose 5. So again, you divide each of those counts by the total count, and obviously your probability should add up to 100. And notice that like just having a high card, like half the time you're going to have a high card, and then another 42% of the time you're going to have a pair. So it's only 7.63% of the time that you have a hand better than a pair. So it's crucial to learn how to play when you have those times, because 92% of the time, just above 92% of the time, you're not going to have good hands. At most, you're going to have a pair, and often that pair is not going to be the best pair on the board, right? So it's for poker, it's really important to learn how to play with bad hands, because everyone has bad hands, right? So you need to learn how to bluff and make the best out of every hand. So let me know if you have any questions below. Obviously, this is a hard topic and it requires a lot of practice. It's kind of this weird thing where it's feasible to do in high school, but they also do it and struggle at the university stats level. So I encourage you to ask your questions in the comments below, and thank you for watching.